in this video. Hello everyone, and welcome to the 16th video on this channel. And yes, this is also the video where I am starting the YouTube shorts of this channel, which will be 60-second lessons. That is where I explain the lesson in under 60 seconds. So if you really want to look at that, it's definitely worth a shot to look at that. And it's going to be posted at the same time as the videos, so stay tuned for that. One more big favor before we go on to the answers to our previous questions is to please like and subscribe for more awesome content just like this. Without further ado, let's go on to our answers to our previous questions. The answers to our two questions over here are shown by graphs, where the graph is in red and the black is just the labeling of the number line and the number line itself. For our first question, we have two open circles and a line connecting them in between. And for our second question, we have two closed circles and two lines going in the opposite direction. If you haven't realized this, the first one was an AND problem for the inequalities, and the second one was an OR problem for the inequality. Now, let's move on to the lesson. I know this looks like a lot right now, but let me take you through step by step. Number one, let's start with the exponentials. As shown over here, I'm below my squiggly line. This is where I define what an exponential is and the form of an exponential. We have the base and the exponent. It's kind of like x squared, except we flip the 2 and the x, or it would be like 2 to the x. Like x would be the exponent and the other number would just be the base. Also, in this box on the left of the exponential section, we have e to the x. E to the x is special. It contains Euler's number, which is around 2.7. It's also used in many fields of advanced mathematics. And it's also very useful because 2.7 Euler's number is also very prominent in nature and other things. Okay, I think you got the exponential part. But what about the opposite? What about the stuff on the bottom? My friends, that's called the logarithm. That is the opposite of the exponential. So if I had 2 to the x, the opposite of that would be logarithm base 2 of x. So what I mean by this is, let's say I had logarithm base 2 of 2 to the x. This would just equal x. It's also true the other way around. If I have 2 to the power of logarithm base 2x, this is also equal to just x. This is what I mean by opposites or inverse functions, which I will actually cover, but that will be in a future video for Algebra 2, not right now. And if any of you who are wondering what was the opposite of e to the x, it's actually a little special. But instead of logarithm base something, in this case it would have been logarithm base e, we write natural logarithm of x. This is the exact opposite of e to the x, just like the regular logarithm and the regular exponentials are opposites. I think it would be easier to see what we're talking about and why I introduced you to all of this in the examples. But one more thing, this is actually one of my favorite topics in Algebra 2. So I was actually quite looking forward to this video. I'm like, yes, it's this topic, let's go. So let's move on to the examples. Today we have 3 examples. In each of them, we're going to be solving for x. Our first example is logarithm base 3 of x is equal to 4. So, what we do is, let's say we wanted to find out x squared is equal to 4, okay? What we would have is we would take the square root of both sides and find out that x is equal to either positive or negative 2, okay? But if we wanted to do this, it would be the exact same thing. Logarithm base 3x is equal to 4, we would do 3 to the power of everything, because 3 to the power of logarithm base 3 of x is just equal to x, and 3 to the 4th is equal to 81. So what we would get is x is equal to 81 for our first answer. Our second question, we have 4 to the x is equal to 64. If I write that up here, I think it would also be simple to figure out what to do. We would have to take the logarithm with the base of 4 on both sides. because if we did that, we would get x on the left-hand side, and on the right-hand side, we would get our answer. What is shown here, logarithm base 4, 4 to the x, that's x. Now logarithm base 464, 64 can be written as 4 cubed. Now logarithm base 4 of 4 cubed, or logarithm base 4, 4 to the x is x. So if we just replace x with 3, we would get 3. So x is equal to 3 is the answer to our second example. For our third and final example, we have the natural logarithm of e to the x is equal to 5. This is actually even more simple than the first two examples because natural logarithm and e to the x are opposites, and we don't have to do anything on the right-hand side. So if natural logarithm and e to the x are opposites, that would make it x is equal to 5. So that's the answer to our third example. Of course, none of our problems would be complete, none of our lessons would be complete without some practice problems. Our 3 practice problems for today is 5 to the power of x is equal to 125. The second one is natural logarithm of e squared is equal to x. And our third one is logarithm base 6 of 36 is equal to x. Thank you so much for watching, and see you in the next one. Bye-bye.